data communication and computer networking technologies. Right. Okay. First of all, let me briefly discuss what are we going to do in this unit. So this is unit number 6. So in this unit, we are going to look at basically what data communication is, which actually we have done in O levels as well. But we go into more details. අපි O level වලදීත් මේක කතා කරපු එකක්, but අපි මේකේ තවත් දුරට details ගැන කතා කරනවා. So the first few parts we talk about what data communication and the elements of the data communication. So we will discuss the details such as what you mean by a communication model, different signal types and their advantages, disadvantages, the properties of signals, and so on. Then we will also look at, in definitely when we have data communication, we have to have a medium, which we also discuss in O levels about guided transmission media as well as unguided transmission media, and then properties of those media. So that is additionally. Then we will also discuss some of the encoding, which means how we can actually put data. So we modify signals, what we call frequency, amplitude, and phase. So we are going to look at those details. So the first part, basically, we look at data communication part of it. Now, after the first part, we are going to look at more on network technology side. We will look at how we can construct computer network, like network topologies, like bus, ring, star, and so on. And then we will discuss some network equipments. Then we will also look at some protocols. ඒ කියන්නේ අපි O level කතා කරපු එකම තමයි පුතේ, නමුත් networking technologies ගැන අපි තව දුරටත් කතා කරමු. Then we are going to talk more on protocols. Protocols we have learned earlier, like HTTP for hypertext transfer protocol, FTP for file transfer protocol, and so on. Right? Now, similarly, we are going to look at how protocol works, different transmission models. Then we are going to look at IP addresses. So already I hope you remember IP addresses, but we are going to go into details, different classes of IP addresses, and how we are going to, subdivide the, computer network and so on. So this is the sometimes the difficult part of the networking module, but the other parts are more or less the theoretical part. Then after finishing this one, finally we are going to look at a little bit about different protocols, TCP/IP. Then OSI model and so on. And then we will finally, at the end of networking part, we will also look at things like security aspect of networking. That when you connect to a network, anybody can come in, right? So those details we will discuss. So that is the summary of data communication and computer network technology. So the first part would be the data communication. So today we will start with that part. So let's start subtopic, data communication. Right, so here is the subtopic, data communication. Right. Now, when it comes to data communication, when we say data, we have to transmit data from one place to another place. අපි data communication කියවහම එක තැනක ඉඳන් තවත් තැනකට යවන එක තමයි අපි මෙතනදී mainly කරන්නේ. So we can say we can use different technologies to send data from one place to another place. So let's write down under this. We can say data communication is the process. So it's a process of transmitting data between two or more devices using some transmission media. Right. The meaning of this is when it comes to data communication, we have to transmit data from one place to another place. So simply we can say it will be between two or more devices. But if you look at early days, sending data from one place to another was a very challenging task. It was time consuming. But with the development of technology, especially networking technology and related networking devices, now we can transmit data from one part of the world to another part of the world within a couple of seconds time, not even minutes. Very fast. අපිට දැන් තාක්ෂණ දියුණුවත් එක පොතේ විශේෂයෙන් පරිගණක ජාල කරන තාක්ෂණ දියුණුවත් එක්ක අපිට ඉතා ඉක්මනින් තොරතුරු හුමාර් කරගන්න පුළුවන්. ඇත්තටම Zoom කියන ටෙක්නොලොජි එකෙන් අපි මේ මොහොතේදී මේ කරන්නේ, right? It's because of we are transmitting my voice, you will hear it, right? And we don't feel that there's a delay. Although there are small delay, you don't feel. So that's the beauty of this information technology. So we can write down with the development of technologies. Now we can transmit data from one place to another, right? Place within couple of seconds. So this is easy, or this is possible because of new technologies. Now, when you talk about this, we need to talk more on the model. Now, we know that we have to have two parties. Now, how do you communicate? That we need to discuss. So let's look at the model for this. So we can talk about a communication model. So one side, right? One side we will normally talk about sender or a source, and the other side we can talk about somebody who's receiving this. We can say receiver or destination, right? And then, so this is the place where we start the communication. This is the place where we receive the communication. So there'll be a message going from here to here, right? So the message is going from sender source to receiver destination. So that means what we call for this is the message. So what we have is the message, right? And then message is transmit from here to here. And then the whole system we call transmission system. And what we have is protocols. Protocol means nothing but some procedures, which we will talk about, right? We will say protocol. Right? This is through a protocol. We are going to access it. So the whole system we can talk about as transmission system. So we can say this is the transmission system. So what you need to get from here is the transmission system. You have at least two parties who's generating the data and will send it to some other place where you receive the data. Right. So let's take down. So let's look at the details of this. So we know that the communication model, we have a sender or source where the data is generated or prepared to be transmitted. So the next one we have all together, this is known as a transmission system. So that means it's a system which is responsible for sending data from one place to another. Now here, the data generation, the starting point we know as source, and the receiving we will call destination. So the data will be transmitted from the source to destination. The next one we are going to look at is the receiver or destination. Now, once you send the data will be received by the receiver for a destination. And that will be the next part. So we will have receiver, destination, and it will receive the data. So the data will be sent from the sender, right? And then receiver will receive the data. Next, we need protocols. Now, protocol is simply a set of rules which controls or which defines how the transmission happens. Okay, or else in other words, we can say what is the procedure for sending data from one place to another place. So that will be defined by the protocol. I already told you, for example, if you take hypertext transfer protocol, which defines how web pages are transmitted between two computers. So protocol is important. And then finally, we can talk about the message. So the message will be the data that we are going to send from source to destination, right? So it will go from source to destination. That is the message. right? To summarize from the beginning, so the any transmission model, we can find out the starting point where the data is generated, that is we known as source. And then we have a transmission system. We are responsible for sending data from one place to another, and the data will be received by the receiver or destination. And then there will be protocols which are responsible for transferring data from one place to another. Exactly, there should be a set of rules to follow. Finally, the message, that is the data sent from source to destination. So in this part, we are going to talk about the signals and their properties. Now, when we talk about, signal is nothing but simply we can say it's a electronic voltage or a current which we can use to transmit data. So this electronic voltage current basically varies with time. So let's write down. So we can say a signal is an electronic voltage or current which varies with time. And this signal we can use to transfer data from one place to another. So we can say that this will transform one place to another place. So it is used to transfer data from one end to another. So in telephone conversation, if you take it an example, telephone conversation, we have sound waves. Our sound, it's a wave, but to transmit, you have to convert this wave into electronic wave. Once you convert into electronic wave, then you can transmit to the destination. So as a first step, we need to first convert sound wave into electronic wave. So we can say in telephone conversation, sound wave, we need to convert into electronic wave. And that we are going to transmit to the destination. Now, once you receive, then you know what you are receiving is electronic wave. To get back the sound, you need to convert back. And that is exactly what will happen. So, electronic wave, then we want to convert back. So, we can say, right, to continue the same, we can say the electronic wave, we can convert back to the sound wave. So the next thing that we need to discuss about the different types of signals. So when we talk about the type of signals, we have what we call analog signals. Analog means the value, the signal varies with the time. It is continuous. Sometimes we say continuous means it will slowly increase, then decrease, then increase, then decrease, and so on. Right? So let's first put with analog signals. Now, analog signals are very commonly used. So let's first discuss what an analog signal is. So as I told you earlier, when we talk about analog signals, it is change over the time, right? So when I say change over the time, what it means, one side, right? So one side right? So one side, we have the time. So for example, if you take this one, so one side, we have the time axis. This is normally say time, right? If I say T, the other side, normally we have voltage. So this is voltage, we normally say. So what you can see is it's going on like this, which means it start with 0, goes up, then it changes the direction, goes down, again goes up, goes down. So it will vary with the time. And this is exactly known as a wave. And this is called analog. Analog means this is continuous. Continuous means keep on increasing and then decreasing, again increasing and so on in that fashion. So this is called analog signal. Right. Now, if we write what an analog signal is, so let's take down. We can say analog signals are continuous waves, right? So many of the things, works as analog signals, right? So we can say under this one, analog signals are continuous waveform, right? Such as sound goes in this manner. Light also goes in this manner. Temperature, or even you can say in this manner. So it's work as a analog fashion. Right. Now we have not talked about the properties of this, but I will come to that point. For example, in waves or the signals, we have some things we should know, like amplitude. That means the maximum or the minimum height that you can actually take, right? So there are things like amplitude, frequency, wavelength, phases that we need to discuss, which I'll come after this. Right. So the next thing that I want to discuss is what are the advantages of analog signals? I told you it's continuous waves, which means it starts from 0, keep on increasing, it goes to a higher state, and then you go back. It goes like this. So the advantages, let's take down under this. It uses less bandwidth. I'll come to that point later. The amount of space that you need to send data. Use less bandwidth and accuracy is high. But then there are some disadvantages as well. The cost is high because you have to record in this analog sound into a tape, which takes time and it's costly as well. There could be noise with this. And then when there are errors, there's no correction. So these are some of the problems in analog signals. Right. So let's write down. So when we say analog signal, we can say, okay, the advantages. So a couple of advantages we can talk about. It uses less bandwidth. Right. Now we are discussing about the analog signals. What you need to remember about the analog signal is it's a waveform, which means it could be voltage, and that will vary. It is continuous, which means it's slowly increasing, then decreasing, again increasing, and so on. And if you take sound waves, light waves, temperature waves, so these are comes under analog signals. If you take the advantages, it uses less bandwidth compared to digital, right? So when you say less bandwidth, it'll be more efficient. Otherwise, you need more resources when you want to send, for example, digital signals. And the accuracy is high compared to, digital. Then there are some disadvantages as well. The cost will be high compared to digital. And noises are there. For example, when you have analog signals, the sound quality may degrade. And when there's some error happens, there's no way to correct it. So that's what we have with the analog signals. Right. Let's move on to the next one. Then we'll move on to the digital signal. So let's write down the next one. It's called digital. So we know in computers what we are using is a digital signals. Right? So this is called digital. So in digital signals, on the other hand, what we have is two discrete levels or two different levels of voltage, right? So simply we can have voltage low and high could be used to represent digital signals, right? So when you talk about digital signals, right? When we have digital signals, we have low and high. Now, for example, I told you this is a voltage or a current varies through the time. So if you draw, right, the two axes, it look like this. So in this axis, we have time, t, time will vary. And in this side, we have the voltage. We can have voltage. So it's basically two levels, assuming that this is zero and this is positive. So first few time, it'll zero, then this is positive, this is again zero, positive, and so on. So you will have two levels of voltage information, right? And when we see digital signals, simply you can see it has only two levels, two voltage levels. And mathematically, when you represent, we can say the lowest one is zero and the highest one is one. That's how we represent binary, right? So if you talk about more on digital signals, we can say, right, they represent two discrete voltages and two values to present something. Only two values to present something. That means 0 and 1. So now that we have discussed about the digital signals, we know that there are two levels, two voltage levels, and we can represent using 0 and 1. So inside the computer, everything we represent using this form. And this is what is exactly happening. Right. Now, if you look at the advantages, the first one is inexpensive. And then the data can be what we call encrypted. That means nobody can read the data. So the privacy is preserved, meaning like nobody can access your data, and the errors you can correct it. So these are the advantages. So error correction we will discuss later on. That means when you're transmitting, you see sometimes there could be some errors. Using different techniques, we can recognize them, we can correct it. But then disadvantage is you need more bandwidth, larger bandwidth. And synchronization, when you want to like have the same values, let's say, right? It's difficult, right? So let's write down this. Advantages and disadvantages. So inexpensive means easy to with a minimum cost you can convert in between. Data could be in encrypted. So some of the data is available for the authorized person. But main disadvantages are larger bandwidth, and the synchronization, the copies usually. Now, for example, sometimes we'll have data in the Google Drive, and at the same time, we have a data in our hard drive. So then whenever we make a change, remember we need to change in multiple places, right? So this we can automate, meaning we can automatically synchronize if you want. And that is known as a disadvantage. Now we have discussed analog and digital signals. Let's look at the properties of these signals. Now, when you describe a signal, we use these properties to describe them, right? Now, for example, the height of the wave, we normally call is amplitude, right? So then we'll talk about frequency. That means how many, waves passes the point, right? Within, let's say, a second, right? So that is we call frequency. So likewise, when you want to describe different signals, we can use them. So let's look at those properties. So let's have a subtopic. So under the subtopic, what we are going to do is discuss is right. So the next topic we are going to talk about the properties. So when you talk about the properties of signals, right? So let's start with them. Now, when you say properties, as I told you earlier, we can use them to describe different types of waves, which is very important for us to discuss. So different aspect of, different types of signals. So the first one, let's look at that. We will call amplitude. So the first one we call amplitude. Now, what amplitude means is the height of the wave. Simply, we can say it's the height of the wave. So let me give you an example. So let's look at this graph, a simple one, right? And you can see this graph shows you a simple sign like a curve, keep on increasing, and at some point it start decreasing. And here we have the lowest possible value, then keep on increasing. So this height is known as the height of the wave, right? We can say height of the wave. And that is what we call just amplitude. Amplitude. So we simply can say it's the height of wave. Right? Okay, draw this. So the next property that we are going to discuss is called frequency. Now the frequency property is very important. We can say that how many circles that happens within a seconds, we can call it frequency, right? So let's say I'm going to have like couple of signals. This is actually two types of signals we will see. So in first signal, you can say within a second, there are 60 cycles, right? There are 60 cycles. We can say that, okay, frequency is 60. Here is less frequent. For a second, there will be only 30 cycles, right? So we can say that, okay, number of cycles per second, so 1 second. That we can say the frequency. Now, when it comes to frequency, we measured in a unit called hertz, or in short, we say HSL. HSL. So we can say that the number of waves So let's look at the other property. So when we are talking about the signals, the other property that we are going to talk about is called wavelength. Simply, length is between the adjacent values, meaning the same set of values, right? Now, for example, let me give an example figure. Let's take this. So if you look at carefully, if you take hills or valleys, right? In this one, you can say the hills, the same value. So this length is called wavelength. But the bottom ones also, if you take the same, you will get the same length. So we can say, right, adjacent ones, right? Adjacent ones, we are getting this. We sometimes call crest. That may hill occur, we call no crest. Or sometimes called valleys as well. Right. So let's write down the distance between the adjacent crests. So usually we can measure in meters. So this is between the adjacent crest, meaning the hills, or even valleys you can take, you will get the same value, the wavelength. And the measurement is called meters. The next topic is we call phase. Right? So the phase means the difference between the same hills or the valleys. So let's look at this figure. So in this one, what you see is, right? Now here, two waves in this particular case, two waves. But if you take the difference between the same point, in this case, we are looking at the hill. And if you look at the difference, so this is called phase difference. So simply phase means a position of a point, right? Position of a point. So we can say the phase is, right, a position of a point on a waveform. The next one that we want to discuss is properties, sorry, propagation. Propagation speed in media. Right. So when we talk about the propagation speed, we can say this is the speed, right? So this is the speed. We can say the speed which a waveform travels with a medium is called propagation speed. This is equal to multiplication of frequency and the wavelength. Right, right. So after that, this is 6.2. We want to look at, right, how different things affects, for example, latency, bandwidth, noise, attenuation, which we'll discuss, distortion, once you actually transmitted signals. So simply to start with this part, we are going to learn about the wired connection, so the guided media. Like if you remember, in the O levels, we look at twisted pair cables, coaxial cables, fiber cables, and so on. And then this could also happen in the free space, which we call unguided media, like wireless. Right. So we need to discuss, these ideas under this. Right. So let's start. So in this one, the first part, we are going to work on guided media. So this is transmission media, the topic. It's, write down the topic. The topic is, we have to list transmission media. Right. So in this one, I'm going to talk about, transmission media. So far we discussed data communication, and then under that, I'm going to talk about transmission media. We are going to talk more on transmission media. Now, when we talk about transmission media, one is physical or wired or guided media, right? So let's start with that. We have the first one. We have what we call guided wire transmission media. So guided means, right, we can say physical medium. Now, when you say physical medium, what it means, right? We can directly use of it. Right. So when you say guided or wired transmission media, so we can say it's a physical medium, right? Physical medium, like wires. Right? So the guided or wired transmission media means a physical medium is used. Send and receive, transmit data. And under that, we can talk about couple of options, right? Now, for example, if you take, right, twisted pair cable, right? Under the guided media, the first thing that we are going to discuss is we call twisted pair or TP. Right. So under the guided media, physical medium we call it. The first one we call twisted pair. So under that, we are going to say twisted pair. Right. So twisted pair means, you know, right. Now, for example, in twisted pair, we can talk about two things. UTP, unshielded twisted pair. Unshielded. Right. So this is how it look like. Right. Twisted pair. So when you say twisted pair, we need to know when are they using this. So we can say, okay, pair of copper wires. Right. Right. So we can say use pair of copper wires with a plastic cover. So you can see here the cover and wires are combined as pairs. So features, low cost, bandwidth also low. Right. Okay. Now this is about the twisted pair cables. Now there's another one under same thing. So this is called unshielded twisted pair. Right. The other one is you can also use unshielded twisted pair UTP. Right. So unshielded. Right. When you have a shielded, unshielded, so simply this is exactly what we have discussed earlier. Right. Twisted pair cables, but under that unshielded twisted pair cable. And there are like different categories in UTP. unshielded, like this one, different categories. Right. So let's, as a final part today, let me put these different types. Right. So under that, I would like to discuss three different types: Cat 1, Cat 5, Cat 6, and their data transmission rates. Look at, they are different. So category 1, Cat 1, data transmission speed is 1 megabits per second. All telephone cables, we had this. Then Cat 5, it's 100 times better, 100 Mbps, max length is 100 meters. Cat 6, 10, and max length is 100. Right? So these are what we call unshielded twist pair cables. So if I show you like some of, Cat 5, 6 values. Just to show you some simple example, right? There are the differences with different categories. Right. Okay. The remaining part I will discuss next week.